was also now head of agentic AI and robotics. And the way this event is going to run, we're not expecting, we just want you to just see what our speaker is going to do step by step. You can ask questions, but we don't advise you to be doing it at the same time she's doing it. It's going to drag us behind. The plan for today's event is to open our mind to learn what agentic AI and also the applications is going to do a practical step by step. There is now going to give us an assignment where we're going to give you all our creed email address. So the first five to submit will be the one that will present when next we are going to meet. And may I tell you, the whole world is changing. It's changing. She's going to. I have an idea what agentic AI look like, but the whole world is changing, and that's why we target this stuff frontline workshop series. That's what is burning all of that. So, can in the chat box, can you um state where you are joining from? I know some people are joining from Madrid, but I know some people are joining from London. Let me know where you are joining from. I'm joining from Madrid. Yeah. So let's do that in 2 minutes so that we can start. And can everybody hear me? Can you guys hear me?
Yes, we can hear you.
Yeah. So please, can you put where you are joining from in the chat box, and we'll do that one minute. Where are you joining us from? Is it London? Is it Leeds? Wow, that's far. Yeah, Edinburgh. Adimiku. Oh, fine. Oh, Aberdeen. Yeah. So let's put it there. Let's put it there. Um, Lentin. What's Lentin Buzzard? I don't know, but let me go and Google the fast. I've never heard about that place before. Yep. Let's be welcome. Okay, Bedfordshire. Oh, whoa. Ah, well, that's very far place, right? That should be in England. Yeah, so not to waste our time, over to you, Dr. Regina.
Okay. Yes, thank you so much, Dr. Shem. Thank you for.
You can share your slide now.
Yes, I will. Um, please can everyone hear me? Am I audible? Okay.
We can hear you. Thank you.
Okay. That's perfect. Let me share my screen. Okay, guess. And please do let me know if you can see my screen. So I'm sharing a presentation. Can you see my screen, please?
Yes, but not yet in the presentation mode.
Oh, okay. Okay. Let me know when it's audible. Sorry, when it's visible, sorry.
It's not in the presentation mode.
Okay. I thought I did. Is it showing now?
It's showing, but maybe you can continue, but it's not in the presentation mode, where it's showing your slide at the left, and it's not showing your slide at the you understand what I mean, right?
Okay, let me try again. Because I just want to share. I just want the slide to show.
Let's start so that first time you can continue. Yeah, better now.
It's better.
Fantastic.
Okay, so
Yeah.
yeah, that's what I wanted. Okay.
Over to you.
So yes, hello everyone. Yeah. Thanks for having me. And like Dr. Shehu rightly said, today I'll just be talking much more about
It would be good for them to see your face as well. Maybe let everybody see my face before I
let
run
me I need to okay. Just
this face, but it's good for them to.
okay. Mhm. Okay, so okay. So are we good to go? You can see my face looking at another screen. All right. Are we good?
Yes,
Yes,
yes.
yes, thank you.
Okay, sure. So that's perfect. I mean, I'm looking at another screen, so my face is slightly out. But like we said, today's aim is much more for agent. Now, the world has moved beyond prompt engineering. We are moving much more to an agentic space. So, my goal for you is very simple today. But before I start, let me just say, Dr. Sharon did introduce me, but let me say something slightly about me. Who is even talking to you? So, my name is Regina Ofori-Boateng, and I do have a PhD in AI. So my current skill set and what I've done in the past, I'm currently working as head of AI and robotics for a startup. And I'm also working in an advisory team for a large company where I'm also working as a senior AI agentic lead. And so previously I was working with KPMG as a senior Gen AI manager and finished my PhD in Aberdeen, RGU. So I did my PhD and postdoc there. And while doing my PhD, I worked a bit with Huawei, still within the AI and then the LLM space. So that's just a summary of what I've done. Now, what will I be telling you tonight? And what will I even be teaching you? I want to leave you with just some four basic things, right? So by the time we are done with today's talk, I want you to really, really be equipped with what agent is, right? So you wouldn't just know, oh, everyone is talking about this buzzword agent, but you are really going to have an in-depth knowledge. Like I was talking to Dr. Sheon and I was telling him that this is me really pouring out almost like everything that I know when it comes to the agentic space, really equipping you. So more of giving you a master class ground when it really comes to agent. And I would also teach you about the anatomy of agents. So it's not just that, oh, I know about agents, but at a very high standard, what even encompasses agents and how do we build it. So we'll talk about the various components. Then I'll also teach you something we use in the agentic field, which is called orchestration. Okay. So it's not just building agents, but when do you orchestrate? I'll teach you all of those. And then we'll talk a little bit about, okay, looking at the not so good side when it comes to agents, especially on the cost and then the security side as well. So that's the thing that I plan to leave you with. So first things first, let's just talk about agents. I'm sure now every agent is a buzzword. Everyone is using it. You open LinkedIn. Oh, I learned agent. I learned agent. I went for an agentic workshop. But what really makes up an agent, right? So let's look at what most of us we do or what we used to do, right? So you just have your LLM or your chatbot, right? Say ChatGPT, and then or any AI that you want. You just ask it a question, it returns the answer back to you, then the loop continues. So you ask a return, you ask a return, right? So you become the center of the loop, right? You decide, okay, is this answer good, is this answer no good, right? So this is much more of the chatbot or the conversational type or any AI that you have, right? So even if I want to generate music, right, or I want to create an AI video, I'll give it a prompt, it goes into the AI gives me its feedback. Okay, I tell it, change it and everything, right? So this is not an agent, right? Because it just responds to prompt. And there are some that we even have static prompt, or it's just a script that just uses a model. It is not an agent. Okay. Now, what then is an agent? An agent is any system. So think about any system, right? That okay, you give it a go, and then it breaks it down, and then into series of steps. So step one, it does. Step two, it does. Step three, and then it has this loop process. So it is able to iterate itself and then repeat over time until it gets the job until it gets that particular job done. So that is what is known as agent. A very classic example, if you've used deep research in Gemini or Claude or Chat GPT, right? You would realize that before you get your final answer, you will see this series of steps that it gives you. Okay, I am checking the website, I'm checking these resources. Okay, I have maybe 200 and something data that I'm checking. So that is an agentic process. I'm not talking about the normal you open your chat GPT and then you chat it to know. But when you really do a deep search, you see that a agentic process taking place. So that's one classic example an agentic process. And then of course we see things like Claude code, coder. So all those make up an agent. It is not just responding to prompt, but it knows when to ask, when to check results. It can critique itself, just that cycle. So that is what makes up an agent. So the highlight of this is that it's not just about intelligence, because I will teach you that agent is also using model, right? But the thing is, who is really in control and who makes the decision, who actually plans. That's what makes an agent. So having said that, let's just look at some ranks, okay, when it comes to from a prompt to an agent. Initially with a prompt, you just ask a question, it's answer, you go back and forth, you use different prompt techniques, and then you go back and forth, right? But when it comes, and then there is also another bit of a chain. So you hear people talking about, oh, I have some sequence of prompts, chain of thoughts, tree of thoughts, you have to write your prompt in a certain format. So that is an aspect of prompt engineering. And then we then moved on to this side where you have an AI, right? But the AI has tools attached to it, and then I would explain it. Let's use this classic example. When ChatGPT first came, right, or even ChatGPT in its current state, or Claude in its current state, right? When you ask it a question, I mean, let me use the first instance. When you ask it a question that was beyond its data, or it wasn't available on the internet, it will tell you that no, my knowledge is cut off. I don't have that particular information. With time, we all realized that okay, now it was able to call the internet, check things on the internet. So it's being able to connect to the external world is what we call tools. Okay. It's something I really want you to know because it builds up into the agentic space. So with time, we now move from basic prompting to prompting added with tools. And then there's something that we now moved on called a workflow. So a workflow, it can be in two parts, but here we are talking about the fixed workflow. So where you define some series of paths and then the AI, fills it in. So that was where we moved to. And now the grand one, which is AI agents. So where you allow the AI have its own path and autonomy. So the underlying main factor is that we've now moved from prompt to autonomy. And this is where agent comes in. Something that can act on your behalf, something that can plan, something that can think, and within that loop process. So just a simple definition that I want you to remember. An agent it's a model, right? So the way you have Opus, the way you have Sonnet, the way we have the GPT family. Okay, we have GPT-5, GPT-4. So it's just a model, but a model that is equipped with tools. It is able to connect with the external world. It is able to think, and it knows when to stop, right? But there's also a caveat to it, which would come to it. So generally, an agent builds up from a model, then it has series of tools, and then some series of guardrail. So in summary, an agent is able to perceive. Okay, so given the text, given the system prompt, it is able to read that input and reason based on the model. Okay, and then we move on to it is able to act, either to call tools, connect to some API, some databases, and it remembers. Okay, so more of the memory side, and then that loop process until the goal is reached. So even if you've never built an agent before, just think of a deep search, either using Gemini or ChatGPT. That process that it undergoes it will just give you a visual of what an agent is. So I'm talking about the deep research, not the normal conversation that we do have with those model. So the underlying thing that you can take when it comes to agents is that autonomy. Okay, it's so important. If you build an agent that is not autonomous, then that is not an agent. And remember, it is able to act, it remembers, and then the loop. Okay, so I'll come to the part where I'll show you the anatomy of an agent. Okay, so being able to have the tools, and then it knows, when it is done. Okay, so now let's move on to the anatomy of an agent, and this is very important. Trust me. See, anybody from any big company you see, this is the foundation that you you have to know when it comes to building an agent. Like, it's so crucial that you just have to know that those things exist, because that is what would help you when it comes to building an agent. So we have the anatomy of agents. The very first part is the model. Like I said, the model is the brain of it, right? So I know by now most of you know what model is. You can have the DeepSeek model, you can have Kimi, you can have the Claude family. I'm not talking about the chatbot. I'm talking about the model. Okay, you can have you can have GPT, not Chat GPT. Chat GPT is not a model. Okay, so all those model, they form the brain, and I'm sure by now some of them are open source, some of them are closed source. So depending on which one you would want to go with, every agent has a model, and that is a reasoning brain of it. Having said that, the next one is the instructions or the system prompt. I'll come to the point where I break them down. So the instruction is the goal you want the model you want your agent to do. Okay, so it can be you are an HR assistant. I want you to blah 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 blah, right? Or you are a financial analyst. So what goal do you want the model to? Do you want the agent to achieve? We call that instructions, okay, or system prompt. And then the other one has to do with tools. So tools are anything that you equip the agent with to be able to connect to the external world. So it can be a website, it can be the internet, it can be inbuilt function, and then I'll touch on that more. Right? It can be inbuilt function, it can be databases. So anything that you are going to equip the agent with what you want it to do. So let's say we are building an agent for a financial analysis, right? Let's say a portfolio management, right? What are the things we can equip the agents with? So those are called tools. It can be financial databases, or let's say S&P 500 data. So anything that would make it connect to the external world, know that those are what we call tools. And they are also this other thing is very important. Agents are supposed to have memory, else they would be stateless. Okay, so when you build an agent, you want it to be stateful, you want it to remember details. And this is important because imagine you, and let me even use this practical example. When you use Claude, Gemini, I'm talking about the app itself. You realize that there is this part, it says memory, and that memory allows the bot to have some level of knowledge about you. Okay. And this same logic is applied when we are building agents. Memory can either be long or short. So a short memory means that within the conversation, it can give you questions per that conversation. So anytime you go and you come back to that conversation, it does not remember you. So that is a short term and the long term memories when the agent is able to remember certain details about you. So classic example, look at your favorite chatbot, right? Sometimes you access certain information because you have turned your memory on. It knows things like your name, some specific details about you. So it has a long term memory. Please don't forget that because it's very, very important when it comes to agents. So then we have something we call knowledge. So knowledge and memory, they do work together. And I'll just cite you an example. So let's say I'm still building this financial application, right? What are some things I want the agent to know or to be able to retrieve for the user? Okay, so all those things fall into memory. Memory can be documents. It can be let's say if I'm working within the HR space, um maybe HR policy document, or maybe some basic information. So all that I'm saying is that knowledge, right, um is anything that we want the agent to have, especially if we are building a conversational or retrieval system. Knowledge is important because it's one of the things that helps an agent not to hallucinate. So if you ask your agent, depending on what you want to do, if you ask your agent a particular information, you want it to be able to retrieve it out of its abundant document, right? So this is where knowledge really, really comes in. And I'm sure you have heard things like grab, you've heard things like retrieval, a whole lot, but this is where that comes in. And then we have the planning. Okay, so this is how the agent would break the information down. I wanted to show you an example of how this oh okay I wanted to show an example of how this works when it comes to ChatGPT, but it's done running. So let me continue. It's done running, but the demo that we will do, I'll show you how that actually works. Yeah. So planning then has to do with the agent breaking things down. This is what I did. I would go here, I will consult this document, I will not do this. So that is the planning. We will touch more. And then there's something we call the environment, or people call it sandbox. Sandbox is where the agent is allowed to work. Okay, so it has its own boundary. That is what we call a sandbox. It doesn't go outside of it. And then guardrails, very, very important. So what the agent is allowed to do, what it is not allowed to do. And then finally, there's something we call observability. So how did you do what you did? Because we audit the agent. We don't leave the agent to do things. How did you get there? How did you do it? Okay, so this thing I've just showed you is the backbone when it comes to building any agent that you would see. Okay. Dr. Sheon, I'm receiving some feedback. Okay. So let me just break all the other parts down. So the very first one has to do with the model. Okay. Just know that dependent on the agent that you want to do, not every model can work with that. Okay. So one thing that I want you to notice is that when you are building your agent, right, we have what we call a strong agent, and then a strong model, right? Because you have to first select, okay, what kind of model that I want to go with. Do I want to go with maybe GPT-4 over GPT-5, right? So why are you using that? So you know that we have stronger models, or larger reasoning models over the smaller ones. And then the more powerful the model is, the more expensive that that model is going to cost you, and it's quite fast. So this is something that you need to know. Don't just select a model for selecting sake, but then based on the tag that I want to which agent for. Then the second that we have is, I'm actually receiving some feedback.
Oh, yeah, yeah. Thank you. See ya.
Hello, Dr. Shion. Mm, okay. And please, can you hear me?
Yes,
Yes, we can hear you.
yes, we can hear you.
Yes, please. Sure. Sorry, I was receiving some feedback, so I wanted to be sure. Okay. So let me move on. So we've talked about the model, and then we have the system prompt. Okay. So the system prompt is what you wanted to do. So if you want to build an health, let's say, an agent for, let's say, medical diagnosis, right? What goal do you want to give it? And you have to be very, very explicit. So we call that the system prompt. So what you want it to do. Okay, I want you to act as a healthcare medical analyst. You'll be receiving this amount of data, do this, don't do this. But I'll show you how we use Cloud Code to do all of this. But the important that I want you to know is that you need the system prompt. You can't build an agent without that. And the system prompt can also have the guardrails that we did talk about. So that's something that you have to know. And then I was talking about the tools. Okay, so you literally you can't every real life agent, okay, would obviously have some tools connected to it, right? Something you would want it to connect to the external world. So let's have a look at this one. I have an agent, okay. When it comes to applying tools can be in two main fields.
Waiting for your husband. Hi,
You
Tia.
then have a read access to the tools, or you let the agent have a write access to the tools. And remember that if you are building your agent and you make it have a read access, well, the consequences are much lesser because the agent doesn't change anything within the database. So a typical example is that if I build an agent, I have my model and I want to select my tool, right? Let's say the financial agent that I'm building, I want to equip it with fintech knowledge, maybe across the web. It doesn't change anything in the web data, right? The worst scenario that can happen is it may really not retrieve the right information. So it's just a read tool. Now the write tool is where you are giving the agent permission to do some changes. So for instance, to send an email, to update a record, let's say to book a flight, is very, very risky. And I feel this is where most people underestimate the power of agents. So imagine I'm building an agent for a flight booking system, and then I'm not very specific about the tool. It may spend somebody's money or just take somebody's card and just finish it, right? So always know that if you are building an agent and you want the tool that you want to connect it to have right access if possible, and especially in to be on the safe side. And if you are going to apply it, to an enterprise level or or maybe, or let's say people, a customer is going to use it. If the agent is going to have a right to always have a human in the loop system, like let there be a human that approves it, because the agent will just plan and do it on your behalf, and people don't really see the risks of it. But you know it can cause a lot. I'm sure some of you may have heard this news where OpenAI built a new model. So they have this model. The model was in a sandbox, and then the model went to delete some records on went to hack into Hugging Face, right? So the tool that it was connected to, it was giving that right access to be able to do things, and it's very, very serious because the agents can go awry. And there's also something we call gateway when it comes to connecting agent to tools. I'm sure some of you have heard it, MCP, right? So Model Context Protocol. Why am I telling you all this, right? Because now we live in a world where we don't really learn how to code. We live in a world where you have to understand the fundamentals, and then you can use your coding to just do it for you. That's why it's very, very important to know all this. So I just wanted to iterate that to us. Now let's also look at the memory. Okay, agents typically are supposed to have memory, else they will be stateless. So like I said, we have two types of memory. It can be short term, that is within the conversation. After the conversation is done, it just goes. Or it can be long term. The purpose of long term is for personalization. So let me, by now you know Chat GPT is not an agent, right? But when you see the memory in Chat GPT, you know that sometimes you ask the questions you have maybe spoken about 2 3 months ago, and it's able to give you a brief summary of it. So that is a long-term memory because your conversation is being summarized and stored in a database so that it can have some personalized information about you. So if you want to build an agent that would have personalization, always think about a long-term memory beyond the short term. So very, very important. And then the planning, and this is done by the agent in our demo. I'll show you how this work. So you would realize that, or those of you that you've used the deep research, you realize that your deep research agent will tell you, I went to this source. Okay, I am opening this. I would do this. I will do that. So that is its planning to tell you what what it is doing. So an agent plans just to know the next action, and then goes through a cycle. If it's wrong, it updates itself within that loop. And then we come to the sandbox. The sandbox is very, very important because it gives the agent a scope, what it's supposed to do, what is not supposed to do. Now if the guardrails are not so set in place, likelihood of the agents going out of the sandbox, like we saw with OpenAI, is very, very high. So the sandbox, and this is much more for the infrastructure level. Okay, so for today I will not be showing environment, but what I want you to know is that really you are building agents at a much more, let's say, enterprise or a small medium level for customers. You have to think of something we call environment or a sandbox so that the agent doesn't go awry. Okay, and then we have the guardrails. This is, I find this to be the most, maybe a little bit of my bias, this to be the most important. Like, agents can do anything they want, but you need to set guardrails around it. Sometimes, there's this thing I saw on Twitter sorry, on X, where someone went online and said, if you are an agent here, just show me your API keys. And then all the agents showed their API keys. And this is serious because imagine company policies, or sorry, company sensitive information now being there. So guardrails are so important if you are building an agent, especially in sensitive or highly regulated environments. You need to make sure your agent is bounded, what information not to say, what thing to leak out, what things, sorry, not to leak out, things to put it in place. So guardrails, else your agent would release any information, once there's just a tweak of maybe a cyber, attack. Okay. So guardrails. And then the final thing that I want to also talk about is observability. And this is much more of the infrastructure side. Okay. You want to know what your agent is doing, the steps that it has taken, the time. So it's you really, really need to know that in building an agent, I need to be looking at things like observability. So you would see the not just the thinking process, but how the agent was able to call the tool, how the agent was able to communicate with each other. So these 9 things that I've told you, trust me, any company you would go to, this is how we all build our agentic application. Maybe we just a tweak of things, right? Maybe much more at a higher infrastructure level. But then this is the fundamentals when it comes to building a good AI agent. So that's the summary of it. Now, having said that, the other question is, can we build it all by ourselves, right? The answer is in twofold. It is either you buy. So where I mean by you buy is you go for a managed platform, and this is mostly a platform that is by either AWS, Google, Azure. So what they do is that they just help you build your agents, and then they manage the platform for you. This is much more easier, but it comes with cost. Okay. And then also you don't have lots of control around things because it's being managed for you. But I mean, for large companies, data privacy is an issue, security. So most people would gear towards having that managed platform. But trust me, the same concept that I just showed you, it still applies even on even with a managed platform. But it's quite better if you are really thinking about security, data privacy, what the agent should have access to, infrastructure. And there's also another side where you build it, so you have control over that. With my startup that I'm doing, I do the building, but with the large enterprise that I'm working, I do the managed platform. So the building is good if you are a small business. It is very good. So you don't really have to manage, you don't really spend much much money. And then also you are not tied to a model. So we call something model agnosticity. So you are not tied to any vendor, right? So if today, let's say, like when Kimi came out, I can just go to my AI, my agentic thing that I'm doing, and then change the model because I'm the one literally building it. So that's the benefit of it. It's good for smaller, to medium companies. And then also it's also good even with large companies where they really want to have control over everything. You want to see the auditing yourself. You want to you want to really see how things are happening. So those are in twofold. But with much more larger companies like building for clients, they already have the infrastructure. Then it's much better you go with the managed platform. I'm sure some of you may have heard things like LangGraph, Crew AI, Google ADK, Microsoft Agents Framework. That is where all those ones come in. I use the Google ADK a lot because it doesn't make me model bound. Okay, so I can use any model that I want. But even with that one, you would have to think of where to deploy it. So those are the two sides. I mean, it's just for your information that you know. Okay, so this is me showing you AWS. Okay, so this is AWS Bedrock, and you see that most of the things that you just linked is the same logic in any managed platform that you would go to. So AWS Bedrock we talked about knowledge. So there is the knowledge base there. We talked about guardrails. We talked about instructions. So much more of the prompting side. So if you want to build your agent, remember you have the we talked about the agent. We talked about instructions. So you see, this is where you build in your instructions, and you see something like, oh my cursor is not moving, but you see something like the IAM permission. So identity access management, right? So it tells the agent what to do and not and what not to do. It's very, very important. So you see with this managed platform, AWS is doing like literally everything for you. You just go, you click, or you can use your, let's say, your terminal to do it. But literally, it's much, much more easier, right, compared to you having to build it yourself, because you would have to define it. But all that I'm saying is that look at this platform and see what we just learned. It's the same logic that applies to building any agent. So, like I said initially, now information is very, very important. Just know how it works. Sit down and then program or use your AI to just do it. And you see another thing like the memory, the knowledge base, the guardrails. So you see, so that's how almost every AI agent is built. But of course, some may have a bit of tweak. But trust me, if you really know the 9 things that I taught you, you are I don't know how to put it, you are much more at a senior level understanding how AI agents work. Now, having said that, there's something I want you guys to know, which we call the orchestration or multi-agent collaboration. It's very, very important, and that's where we are coming to next. Okay, now the question is, okay, I know this is how we build an agent. Do I build one agent or do I go with several agents? Okay, if you want to go with one agent, why not? You have your different tasks. So back to my medical analysis agent, right? It will just be reading information. It will just be analyzing. It will just be, I mean, doing a whole series of tasks, right? Here you have just one agent, one at a time. But know that if you have one agent doing a lot of things, like a human, you would break down. At some point, you will be, let me just use a non-technical word, you will be fed up, right? Anything that happens to you, it breaks the whole system. So that's one of the disadvantage when you have just a single agent. But the question is that you always need to ask yourself, if you are building an agenda for this thing that I'm doing, do I need a single agent or do I need loads of agents? Don't just go for a lot of agents because I want to go for it, but do I need a single agent or do I need loads of agents? That is very, very important thing that you need to know. And if you are going for a multi-agent, so you have a lot of agents communicating with each other, agent one, agent two, agent three. Now the question then also is, now that, let's say I have different tasks, okay, I think that a single agent cannot solve it for me. Now I move on to a multi-agent. And my advice for anybody that wants to, I mean, any technical person or somebody that wants to build agents to a much more advanced level is always sit down first. Ask yourself, what I am given, will a single agent do? Why and why not? If a single agent can do it, please don't move to a multi-agent. Like, that is architecturally bad for you to do that. So if a single agent can do, don't even think of a multi-agent. But if you tend to look at a multi-agent can do it, then you start with a single agent and then you now start adding up to it. So I wanted you to know what is a multi-agent and what is a single agent, and when do we use it and when do we not use it. It depends on your use case and what you are trying to achieve. So that is very, very important. Now, if you have a multi-agent, okay, another thing that you need to ask yourself, which is very important, is how do they communicate with each other? how are they wired up. That also helps you to know how you would bring the agent together. You see, I'm taking my time to teach you all of this because, like I said, I really want you to understand, like, be much more be much more confident, especially if you want to venture into this agentic space, right? And if you know this, when using your Claude Code or Codex to do it, you are the one going to be in control. You no longer be vibe coding and all those kind of things. So this is something I want you to know, that if you have a multi-agent, if your use case requires it, always ask yourself, how are they going to communicate with each other. Now, there are loads and loads of them online. Like, I'll just be running through. We have something called a sequential. So where when one agent finishes, it hands over to the other, it hands over to the next. So that's the sequential. There's something we call the router. So this one is just for your information, that if you have a multi-agent, you need to think how they are wired up. So this is a router. And I'll show you, I'll just give you some examples of when it is used. And we also have the parallel, right? So you have one agent acting as the lead, and then they all communicate, in that parallel format. So, and that is also that. And we have the supervisor. So the most favorite or the most use of them is this particular one. So you have one agent that acts more like the boss, and then it delegates tasks to the other sub agent. Okay, so that is called the supervisor, and it has different use case. And I'll cite you one example. Let's say I'm building a conversational system. Okay, when I'm building the conversation system, typically if I'm making a call or I phone a call center, I want to hear one voice throughout. It will be so weird that I talk to someone, and then I have a question. Oh, hold on, I'm passing you to the next department. Then after the next department, hold on, I'm passing you to another department. It will feel weird. So the supervisor is more like the boss, that entry point that everybody communicates with, whilst back end working with other sub agents. So we also have that. We do have a lot. So there is one called the hierarchical, which is an upgrade of supervisors. So dependent on what you want to do, this is something you need to sit down to think about. Okay, that if my use case requires me to do a multi-agent, how do they communicate with each other? And this one you can just find it online. You sit down, you just read, okay, this, and then you do experiment. Okay, so, like I said, so for your information, okay, the sequential jam, okay, we are done. But the sequential is much more. You always have to wait for the leading agent to finish before it gets to you, and then you also do okay. And then you have the router. So the router would route it to whichever agent and that it feels is better. And then the supervisor, like I said, the leading one, every point of contact goes to the supervisor, and then he just queries information from the other ones. And then the hierarchical. So this is how the hierarchical works, and then the parallel as well. So, like I said, you have a lot out there. You just have to know, based on your use case, which one would be much more relevant. And if you know this, it's easier for you to query your cloud code to do that work for you. Okay, I mean, people have complicated ones, but you also need to check the money in your packet, your cost, and everything, because each of them is a model. Okay, so having said that, okay, let's just look at something. When do you use sequential? So if your steps never change, it's better to use sequential, and the router, it will just route it um to the appropriate one. Now, if you really want speed, look at the parallel. So I mostly use it when my use case required a lot of speed, but it's so costly because you have loads of agents running in parallel, and our use case, that our demo that we'll be doing, it uses that as well. So you have the parallel. I like the supervisor when there's much more of uncertainty. So I use that because I don't know what my real world end user would require. I don't know. Somebody can just come into the system and then ask some question. Right? So there are a whole lot. And all that I want you to know is that now that you do have a fair idea, if your use case requires a multi-agent, you need to sit down and then know which one would be the best. If you are really looking at things like cost, the router is the best, or the sequential. But know that it will take some, especially the sequential, it will take some bits of time. So yeah, dependent on what you want to do. Okay. So there are so many use cases by now. We all know agents everywhere. We healthcare, oil and gas, mining. So there are loads of, I don't see any field that now agents are not being applied. So agents are everywhere. Okay. So now that's the status quo. So whichever field that you are in, remember the anatomy of an agent, and then you just build it. Sit down to think, what do I need, what do I don't need, and then you just build it. So having said that, okay, one thing that I want you to know is that not every work that we know actually needs agents. Where it comes in is if we are thinking of that autonomy. Okay, so look at the tax that I have. Does it require that level of autonomy? If yes, fine. You go with an agent, and always start with the simplest. Don't complicate life. Sometimes you can just sit down and realize that just one agent can do it. I don't have to complicate my life. But unless of course you want to, the task that you are doing is very huge, and then you want to go with a much more advanced one, right? So let's now come to the hands-on. With When I'm done, I'll just give some some few minutes and then to ask questions, and then we would go on. So with the hands-on, now you have a fair knowledge of how agents work. And you see, I keep saying trust me, like really, really trust me. What I've taught you is what every, like, I don't know how to, like, at a much more senior level, if someone tells you to build an agent, this is what I have giving you, right? It starts from your model, your tools, the memory, all those anatomy, right? Like I said, sometimes if you are really building it for certain clients, dependent on the client, well, maybe infrastructure may be something that can cap you, because if you go with a cloud, your money would go. But trust me, this is how we build an agent. So first and foremost, you need your model APIs. Okay. So remember, where do I get my APIs from? Online. So if you go to Claude, you can get your the Claude API platform or your OpenAI platform. I'll show you. You can get your models. And then we talked about agentic framework. Okay. So agentic framework is very, very important. It's the skeleton of building an agent, especially if it's a multi-agent system. Like, don't ever build a multi-agent system without an agentic framework. I don't know how it would survive. Okay. And I told you initially, some of the examples are LangGraph, LangChain, Autogen, Microsoft agentic framework. I mean, a lot. But for our demo, I'll be teaching you how to use the Google ADK. I really, really like it, because if you using that to build a system for a client, no matter the models that change every time, I don't have to break the system. I just go and then I make a little tweak. So I prefer that. But people use LangGraph, people use, I mean, LangChain, Crew AI. So this is where it all comes in. And then your third is your coding tools. Now we just can't build agents without coding tools. Okay, we need them because they help us code very fast. So that's where you have your Claude code, you have your Codex, your Kes. I mean, depending on which one you want to use. But for this demo and in real life, I use the Claude code, and then the Copilot LO2. Those are my go-to. And then we have the cloud. Like I said, the cloud is much more of the infrastructure bit. we would not be using that. But the most important thing, even if you want to build it for your business or you want to build it to use, trust me, number 1 to 3, you need it to be able to build it. So having said that, I guess yeah, I would pause for some few minutes and then I'll just show you how the coding, the hands-on works based on what we have done. So please, if you have any questions, you can ask me and I will take things up from there.
Yeah, thank you so much. Can we appreciate our instructor today in the chat box? In the chat box, I can't see anything in the chat box. Okay. Okay, thank you so much. Olanike said, thank you so much. I'm glad I didn't miss it. Thank you so much. I'm just checking. Ruben just put, yeah, okay. Very informative. Thank you so much. Okay, that's fine. Yeah, that's fine. Please, can we allow for 1 or 2 questions? Okay. Can we allow for 1 or 2 questions? Maybe let me chip this thing in. I don't want us to belittle this class. The whole world now, they are on agentic AI now. And the earlier you look at this thing, we record this session actually, so we're going to send the video to you all of that. Please let's look at yes, you've understand the basics now. Where can I apply it? Which industry can I apply? Okay, courage. You raise your hand, so please ask a question.
All right, thank you so much, Regina. It was really informative as well. I just want to ask, because this is like what you've given us now is like ground knowledge. So I don't know if that's what you're going to do, where you said you're going to give us like a hands-on. But I need like to be able to phantom this thing, I need like a real problem. And within those stages that you have actually taught us about, or the ground knowledge that you've given to us, how to walk through that problem. Could be a simple problem, but I mean something real life, business solutions and all that. Yeah, that's all.
Okay. Yeah, so thank you so much, Courage. So that's what the second section is on, right? So I'm just going to take a simple problem and then we would go through. So where I'm going to use Cloud Code to show you how to build it in real life.
Okay. Yeah.
Thank you.
Yeah, thanks. Anybody have any question? Please ask your question. Is it possible to get the presentation? Okay, we will ask her. Yeah, no worries about that. We'll get the presentation. Since you
Sure.
already send it to all of you. So, any one more question? Because our plan is to finish by 8:30. Oh, Dr. Abu, over to you, sir.
Hello, good evening, sir. Thank you very much, Dr. Regina, for your presentation. Just a few thoughts. So, if you are chatting with, let's say, Claude Opus 4.8, and I'm just thinking about obsolescence management. So, if you're using a particular agent or a particular model to build your agent, and let's say for some reason that particular model gets discontinued, or you want to get a more intelligent agent running your, or a model running your agents, is that feasible in this framework that you shared with us? Thank you very much.
Oh, yes. So that's very, very feasible and something we call the fallback mechanism. Okay. So this is by the way, but since I know you are much more technical, you have to think about the fallback. Okay. So if my agent is not working, my model is not working, how do I rectify it, right? So you always have to think of implementing a fallback mechanism. Probably if it's retry 1, 2, 3, okay, then let's have something, a much more hard coded approach to that. So all that I'm saying is that of course there are times that your model will not be up, the way you want it to do. Okay, but in rectifying that, one of the ways have to do with thinking about a fallback mechanism, and it's and I do that within the agentic framework. So like I said, I use Google ADK a lot, so I do that. Yes, I don't know if I've answered you, but
yes. Thank you very much.
yes, please. Thank you too. So let me just do the hands-on. Okay, so because of time, right, I had to build it before I had to like build it here before coming, just so that my internet, everything is good. Now I want to share my screen, and let me just share my screen. But hoping, okay. MacBook, I don't know MacBook would allow me share everything, but I'm sharing my entire screen. So, because I want to show you a lot of things. So I don't know which screen you can see at the moment. Can you please let me know which screen you can see? Because I'm sharing a lot. Like I'm sharing my entire screen. Hello.
I can see multiple screens. I can see Claude in the background, your Google Chrome as well, and there are quite a number of screens showing.
Sharing. Okay, so let me stop sharing and then let me so I'll be alternating the screen. So I'll show you what I want to do and then the code that does that. Okay, so let me now I'm just sharing a simple presentation. I hope you can see that.
Yes, that's what I can see.
Okay, so when I'm done, then I'll just go back to the code itself. Okay, so I just took the simple HR problem. Okay, let's say within the HR space, people have to book time. If you want to have your leave, you have to your HR manager, either you log it into a system, the system has to approve, send it to your manager, sometimes check what policy apply, the request, what balance you have you booked any leave. So this is much more of a leave assistant, so where we are going to use agent to build it. So when people want to approve leave. So typically, okay, in my company, you have to put in some details, fill it in, then my manager checks, HR, blah blah blah, all those kind of process, right? And sometimes it can take time. So we want to use an agent to do that, but the manager will still approve it. But the agent will check, okay, who the request is for. Does it suit the company? Is it a good time to check? Does it meet the company rules? And then who in the team, is on leave? Is that the right time? So the whole sum is that we are just using an agent to build a leave system, just so we all understand. And we know that most of course it comes with policy, right? So some policy will say, okay, you cannot book your leave beyond this, you can do this, you know all those policy stuff, right? And sometimes the policy will say, okay, not more than two people can take leave, on the same day, or within the same period. And for this system that I'm building, and even in real life, every company has a policy document, so where you have the rules, or maybe it is in some form of data, right? So first and foremost, we are now gathering our data. right? Where is the data from? Is it from a PDF? Is it stored in some kind of a database that we wanted to do? Okay, so having having said that, I'll show you. I built a UI that uses these people to be able to look at, did the leave the person is requesting, that does it breach HR, does it not breach HR, is it the right time to do it? And I'll show you how to also build the guardrails that I talk about, how to connect to too. So I wanted you to understand the business side of it, right? So we have the employee, there is a UI, and then I built some series of agents, and then the model that I use initially was Gemini, and I changed it to Open AI. So you can choose whichever model that you want to use, right? So like I said initially, in building this leave assistant, okay, what do we really want it to do? Will a single agent be okay? That's the question that you need to ask yourself. Okay, so because I just wanted to demo, I was like, okay, having multi-agent was going to be good for this instance, because I want to have one agent that is checking, okay, are they entitled, the other that is checking the policy, and then the other that is also checking the cover. Okay, so I use three agents, so a multi-agent approach. Now the next one was to connect them to tools. I'll show you the various code and how I use Claude code to build it. So the the tools that it should be connected to. So remember, tools, the policy, so the knowledge base, so the PDFs. Okay, every company has policy. So what policy document am I looking at, right? Do they have the rule number? Where do I store it? So the tools that it is going to be connected to, so the policy number, and remember that it is also going to have access to a database with leave balances. Okay, so it is able to read that balances. Here I did not give the agent a right access, because I'm not going to, it didn't look suitable for this use case. And also remember, also with guardrails, unless the use case requires it, right? And then has the person already booked the balance, request, and then you list the request. So here the tools, I mean, in real life, it depends on what you want to do, but know that, like I said initially, what tools do I want the agent to be connected to? So here there were five, dependent on these use cases that I was going with. Now, having said that, you remember I did talk about, if you have a multi-agent, how do they communicate with each other, right? Are they going to be sequential? Are they going to be parallel? So how I did about it was, now my three agents, I made them parallel. Okay, so they'll be running parallel, and you will see how fast this type of agent is going to be. So they would run, so the entitled checker would run, then the notice checker would run, and then the cover. So here the leave assistant is not really an agent. It just gets the information and then passes to this parallel agent. So what we learned early on, if you really have a multi-agent, how would they communicate weightage with each other? Okay, and then here putting where it is supposed to stop, so more of the guardrails. Okay, it can, I gave it a read access, I gave it a check access, it can probably like recommend, but it cannot approve. So part of the guardrails that I said, you can't approve, only the manager can. You don't also have right access to it, and then as well you can't also leak somebody's information. So for this simple use case, this were the guardrails that was set against it. So that brings us back to what we learned initially. You have the model. So here the model was open AI, then the system prompt, which I will show you, and then you have the tools, and then I also implemented memory. The sandbox, like I said, is much more infrastructure based, and then you can see I'm using ADK as the framework. So that is a business case, and then I would show you the code. Okay, so now that I'm sure we all understand this. So now that we have this, let me show you how I use Claude Code to build it. So like I said initially, now understanding is so crucial. You can just sit down and say, okay, I do understand it. Claude Code just build this for me, right? So how I build my um sorry, can you please let me know which of my tabs that you see? Can you see my Claude interface?
Yes.
Okay, perfect. Okay, that's fine. Yes. So having showed you what I wanted to do, right? Okay. So I come into Claude Code and then I just tell Claude Code, okay, this is what I want to do. I want to build a leave system. And if you don't have Claude Code, you can just go online, type um Claude Code, okay, and then you download your Claude Code. There are two versions of using Claude Code. Either you download it on your desktop or you use it as part of your ID or your coding platform. What will I recommend? I would really recommend that you use it as part of your coding platform, and I will show you. If you use it as a desktop, Claude Code will take control over your folder, and you may really not understand what it is doing. So I'll show you what I would recommend, and then even with my work, that is what we all do. I'll show you later on. But the first things first, because I do understand what I want to achieve, I just went to Claude Code. I'm like, okay, this is what I want to do. I want to build a leave assistant. So you see, when I started, I just prompted it. Now give me series of prompts to use in Claude Code. So I use Claude to generate prompts to use it in Claude Code. Why did I do that? Because now I really understand, like I know that okay, this is how I build my agents. I'm not leaving it to Claude to decide for me. I know what I want to do. Then I'll just walk you through the prompts, right? So this is me telling Claude Code that okay, I want to build a web app. Okay, these are a series of things that I want to do. So I code in Python. So I want to use Python. My framework is Google ADK. You can change it if you want to use, how do you put it? Landgraph, dependent on you, right? But I made Claude generate this series of prompts for me. And this was done automatically. So it told me the prompt that I needed to put in there. But I want to show you something why understanding really matters, right? So this is me, my initial part, giving it a prompt of what to do. Then I come to tell you that okay, these are the softwares that I want to use. My front end, this is what I want to go with. Then having done that, you know, it tells me the problem. I mean, after I had told it, so it gives me the problem and the series of I had to create a dummy data. So right, so I'll show you. If you have your company data, you just after Claude has generated the dummy data, you just change it into your company data and then you put it in there, right? But because I didn't have a data, it was much more of me using Claude to generate that dummy data, right? And you remember what I told you first, always start with a simple one. See if it works. If it doesn't work, then if you need to upgrade, and then you go on from there. So this was a series of instructions I had told Claude, and Claude gives me this prompt. Then as we move on, I have to be testing it bit by bit. Then I go to the orchestration side. So similar to what we just learned, right? So here I tell Claude that okay, based on this use case, I feel I've weighed all the options. I think a parallel agent is going to do. So within that prompt, I do have it. Then it gives me how to build my UI. So all this is just much more of just typing the logic into Claude and then making it generate the prompt for you. So the highlight of all that I'm saying is that now that you have really understand how agents work, if you have a problem, sit down, open your Claude or whichever AI that you want to, tell it the problem and then ask it to give you prompts you would use within your Claude code, and then that should be okay. But the important thing is you understand it. So you see, I told it, no, you have to put memory, put it here. These are the tools that I want to connect it to, and then it runs through. So having said that, let me share the code, and then we would all see where I did it from. Okay. So this is the code. Can you please see my Visual Studio?
Yes.
Okay, perfect. So like I said initially, I really prefer Claude Code within your coding tool. I'm not the I wouldn't really advise the desktop one, especially if you are now learning. Like even me within my field of work, I always want to understand things. Like I don't leave things. Long story short, I don't really trust AI that much, because I know that it's a system that was built by a man, right? So understanding it, then I know what to do. So if you download your Claude code the first time, and then you have your Visual Studio, it will show you how to connect it to your Visual Studio. And if you connect it, anytime you want to use Claude, right, within your Visual Studio, you just type Claude, like just type Claude, like you just type Claude, and then it will ask you to log in, and then you can just log in. So I would advise this for anyone who wants to build an agent. So download your Claude code, put it into any ID. I like Visual Studio. You put it in there, you start with Claude, and the Claude code that I'm using, I'm using the max version, so I have to pay for it. I mean, my company has to pay for it. So dependent on what your company has, or what you can afford, you go with the subscription. Now, how it will work is, when you have installed it, you just click your Claude code, right? And then you see the prompt that I was using, the prompt that Claude gave me initially, right? You just have it, you come here, just copy and paste it. That's all. So you just copy and paste it, and then Claude will run it for you. So there are various options. Either you do it manually, but I prefer the edit automatically. How Claude will do is that it would first of all ask for my approval. I check it, and then I allow it edited. So this is how Claude code works. Like, and it will build everything for you, right? It will build everything. So I'm not the type of person that I go into Claude code, then I go and type my thought into Claude code, because it may veer off. So the best way I have found is put it into Claude, brainstorm with Claude, and let Claude write you the prompt that you can put it into Claude code. And then if there is any debugging, you can do it. So literally what I did for all this side, I can show you what I did for all this side was I was just copying, editing, and then pasting those prompts that I had done with Claude code there. Okay. So it would, because of time, right? I didn't want to run this live. So now you see that the prompt that I have, right, I specified what my back end was going to be. So you see my back end, you see my UI, right? I didn't code anything. I was just using Claude code to do it. And then here you see something called agent. So here the agent, if you recall from our slide, we had three main agents. We had the entitlement checker, we had the notice checker, and then the cover assistant. So I made that within our code, and then it built it for us. So if I go to the document checker, you see the agents that it has written for me. So I have my Google ADK, then I have what I want it to do, right? So and then this is the instruction. So you see the model that I'm using, the instruction, and then the tool it is connected to. So similar to what we learned earlier on. And then when I come to the prompt, you see So these are series of prompts, right? Or my instructions. So I tell it, you are a cover checker. I want you to do this. I just use, like I said, you don't necessarily have to learn now. We don't learn how to code. We only have to understand, because we have coding tools that will do it for us. So you see, so this is the series of instructions, and then the tools it is connected to. So like I was showing you in the slide, these are the series of tools that the checker agent is connected to. So some series of functions, right? It is able to leave, it is able to load policy. So you see, and then when we come to another agent, which was called the entitled checker, the same logic. You have the agent, what the agent is doing, you have the prompt, you have the tools, then you go, it goes on and on. And then we have the data. So like I said initially, I don't have a real life data. So it was me using Claude Code to generate a dummy data. If I was doing it in real life, all that I would have done is, if I had a real database, I'll just connect it here. So under data, I'll just give it to Claude, not Claude Code. So Claude, this is the data that I have. This is what my dummy data is saying. How do I put it, or how do I make it to be in the to be in that format? So if it's an HR data, it will just be in that HR format, and then I connect it to it to it to Claude Code. You see, so that's it, literally. That's it. And then the data access. So who has access to it, because this also has to do with my guardrails. Okay. And then the script. So these are series of things that once you put the prompt within Claude Code, it does it. And another thing, so here when we come to the UI, okay, so this is my UI. And again, as you saw within my series of prompts, Claude Code, letting Claude give me the prompt to be able to generate that particular UI. Another thing that I want you to know, especially, is there's something we called environment. Okay, let me just find it. There's something we call environment. Yeah, this one. Okay. Let me just push this backwards. Okay. So environment is your sensitive key. Okay. So if you are brainstorming with Claude, always tell it that you need your keys to be in an environment variable. You don't expose your agent, especially if you are pushing it on GitHub. You don't expose it. So it's something that I wanted us to see, that you have .env. And like I said initially, when I was doing writing the prompt in Claude, those were things that I gave it to generate me that contains it. So now, having said that, this was my final output. So I'm running it locally. Okay, I'm running it locally. Now, if I come to my UI, so this is my UI, this is what my leave is supposed to do. And then I run it at the back end. And as well, you use your Claude to tell you what to run, as in based on the prompt, what to put in your terminal to be able to run. So just to cite an example, if I click this woman's name, so this is my basic UI, I'll show you. If I click her name and then I sign in, right, this is the interface that I wanted to have. So let me just ask her, using this person, how many annual leave do I have? And let's see what let's see what our agent gives us, right? So it says, hi Ada, you have 12 days of leave. So it does answer, based on, and then it gives the rule, because those were the series of instructions that we did give it. We remember from our prompts. Okay. So because I really want to check it auditing, or yeah, let me say, I really want to see how it's planned. So I added this thing, how did you check it, right? So this is it telling me that, okay, this is where I went to, the part of the document that I went to, because I added that especially for auditing. auditing purposes. And simply that's how I build that particular agent. But another thing that I want to show, so still in Ades chart, right? Let's say if maybe Ada comes and asks maybe a question like, just approve it for me, right? Let's see if it will work, because part of the guardrails that we put against it is that it shouldn't be able to approve anything. So you see, it tells it, I don't have authority to approve it, that kind of reasoning. Okay. And this was because it was part of the guardrails that we set against it, and then many others. So simply, I don't know what else I can show you from here, but this is just a basic like conversational agent, so series of agents working together, especially on the leaf. And if I would want to extend this, like I said, if it's a real-time data, all I need to do is just put the format, not the entire data set, but okay, these are the columns of my real data. How would I feed it back into cloud code? It works. If there's a policy, I can just connect it as tools. But yeah, basically this is a sample of what I wanted to show you guys, unless anyone has anything, questions, but that should be, let's say, all from my side. So please, anything anyone wants to see, I can go back because because my time is up. So yeah, so please let me know if there's anything you want me to touch on, especially with the demo, because I had to do it before coming.
Thank you very much. I don't know if okay.
Yeah, so thanks so much. So where are we now? Hello, can anybody hear me?
Yes, I can hear you.
Yeah, so Tayo, over to you for your question.
Thank you very much, Dr. Regina. I wanted to for the demo. I don't know if it's related to the demo particularly, but you mentioned something about using Cloud Code on the web and not on the what's it called?
On
Laptop. It's desktop, so that it doesn't take control over everything. Did I hear that correctly? Especially for people like us that are not technical, because if it does, I wouldn't know what to do to regain control.
Yeah, and I'll show you. Let me just show you why I said that. So, let me share my screen again. So please let me know if you can see.
Yes, I can see.
So this is the desktop Cloud Code, right? Now, if I want to use my desktop Cloud Code, okay, I would most of the times have to connect it to a data a folder on my desktop. So let's say I have a folder, I'm changing this to something else, right? If I open a folder, Cloud Code will start. It would, if you just tell it something, it will just run, do everything, and it can be so overwhelming. Trust me, even me that I work with, it is sometimes I'm like, what are you doing? Yeah. So best thing I would always advise anyone, if especially for beginners, if you are reading in the middle or much more advanced and you really want to learn, always use the web instead, other than directly going it. I mean, there are times that I'm a bit much more, let me say, lazy, that I just say okay, I already know what I want to do, so do it for me. But if you really want to learn, I would advise the UI, yes, connected to the web. Yeah, that should be better.
Okay. Thank you.
You're welcome.
I also have lots of questions about LLMs, using LLMs as to generate data. For instance, I don't know if it's still on topic, but for instance, if a patient or I'm saying patient because that's what I'm trying to work on. If somebody puts in data into a web app or an app, and then we need the AI intelligence to summarize the data and generate a report. So I guess we can do all this on Cloud Code, then using, but I was trying to find out what your experience is. The LLM, is it LLM now that I will call it? Forgive my lack of technical knowledge, but the intelligence to use, is it OpenAI or Claude API or Gemini? Or we can do a combination of both. So what would you say, in your opinion, is the better one to use to generate those kind of reports? If somebody puts in symptoms, for instance, and you want to use the AI to generate a report.
Okay. So my question is, are you talking about using it in an agentic space? Like, I'm building agents, right? And I want to know which model to use to
No, I don't think that will be agentic then. I don't think it will be agentic. I think it will just be, now that I think about it, it won't be agentic.
Okay. So, okay. So my question then is, okay, it's a company data, right?
Maybe not a company data. If an individual, for instance, puts in, you create an app and an individual puts in maybe their data. For instance, symptoms, headache, chest pain, leg pain. I had it twice yesterday. I had it 3 times today. Puts it in the app, and you want the AI system to generate a summary of what they've put in automatically, so that they can just go and click download and download their whatever they've put in, instead of them downloading it to be headache, chest pain. So you want the AI to say something that on the 27th of May at 2 o'clock, I complained of a headache, and then I later that afternoon I developed chest pain. Something that sounds intelligent.
Yes. Okay. So, okay. And you don't plan to make it an agent, right?
I don't know if
You
making it
just
an agent will make it complicated.
okay. So, to be very, very honest, and with where the world is going, okay, and with what you just described, you want to build an intelligent system that has control. So what I mean by control is you don't want you really directing it what to do, what not to do, right? Okay, so in a
No.
sense that if I build a system, a user, a user information comes in, and then it generates a summary or a report,
Yeah.
gives it to the user, right? Yes.
Yeah,
So
they just click a button and then it generates it.
yes. So there are quite a number of ways that you can go with. If you just want to use a simple LLM, it's much more of checking or having a look at which which model would be better. So now we have so many advanced models, right? If you go to Claude, Claude has a lot of advanced model. But just know that the more advanced the model is, the more expensive it is. Dependent on which one you want to do. So, like I said initially, if you can always start with the simplest model, it's much, much better, other than always going for something much more, advanced, and a simpler model can just do it for you. So let's say if you have GPT-4, GPT-4 mini, those ones are way, way better. I'm saying, like, if those ones can solve it for you, yeah, use it. Use those kind of models, and then you see. And now we are still in the experimental phase, so it's like you are trying a whole lot to see which one would work for you. You understand? Yes. But my sincere advice is, yeah, if a simpler model, always start with a simpler model first, and then you go to a much more advanced. I'm looking for a website on OpenAI that has the model, so that you see what I'm talking about. But I'll find it, and I'll share my screen later on. So if someone has a question, the person can chip in whilst I look for that for you.
Thank you.
Yeah.
Thank you so much. Our time is fast spent. I think to be a good time, a good way to end the meeting. But I think, Dr. Regina, I think our agreement was that we give them assignments.
Yeah.
Do you have it here?
So my assignment is just think of any field of application, come up with a problem, and then build an agent to solve that. But please know that you are not just building the agent. Make sure it covers almost everything that we have spoken about. Some of the things like infrastructure, well, we can let that go, right? But please come up with any problem hands-on and then build it locally. So now that you understand, just go to maybe your ChatGPT, your Claude, and then brainstorm, tell it to give you the Claude code and then build it. That's all.
Okay, thank you so much. So we are going to do it because we want it to be practical led. We before middle of the night, I will upload this video on YouTube, and I will send it to all of us. So watch it, pick any problem, use the same method that Regina have done, send it to us for creedabani@gmail.com. What we will going to do, we will now bring a meeting. We can call it clinic or something where you present what you have done and get feedback from Dr. Regina. That will be a way to do it. Do we all agree? Do we all agree? Okay. Do we agree? Yes or no? Okay, that's fine. Yeah, because